So as a first step, we have found the couple of n, function of the magnitude n, which is unknown, and we want to calculate. Okay? Now, we have another couple acting on the two rollers, which is the couple due to tension of the belts. Okay? So as you can see here, they presented for us the tension forces. So you have on the upper belt, the tension is towards the left, and on the lower one, the tension is towards the right. So I have two forces equal in magnitude, opposite in sense, and same direction. So they create a couple. Each force is equal to 15 Newton. To find the couple created, I need to determine the perpendicular distance between them. As can be seen in the figure, this distance is given. This distance is 75 millimeter. So I can write here that the couple of T forces is equal to, look, I should choose a positive direction for my couples. Since I considered here the couple of N positive, so I am considering that the positive direction is the clockwise, because look, the couple of N is in the clockwise direction. Okay, then I can put it here like this. Okay, so here if you want to say mn is in clockwise and mt should be opposite. Mt is in the counterclockwise direction, but in magnitude they should be equal in magnitude. Okay, so I want to express now the magnitude of mt. So as I can see in my figure, the couples of T is in the rotating in the counterclockwise direction. So already they are giving opposite directions. So they can, to have a resultant equal to 0, they should have the same magnitude to balance each other. So now I already found the magnitude of the first couple function of n. It's n times 50 cosine 30. Now, since for the magnitude of couple T, of T forces, it's 15 Newton, which is the force magnitude, times the distance separating, the perpendicular distance separating the belts, which is 75 millimeters. So here, if you want, since I used millimeter for the unit of in the first couple, I used 50 millimeter. So no need to convert. Or you convert for both to meter, or you keep both in millimeter, because at the end the unit will simplify. Okay. So now, when I write this equation, the only unknown is the value of n. So I can deduce what should be n to have a resultant couple acting on the system equal to 0. Any question on this problem? Okay. Another example. Determine the resultant of the two couples shown in the following figure. So here in this figure also, I have the representation of two couples, and I want to find their result. Let us start together with the easiest couple. The easiest one is the couple of 30 Newton. Why it is easier than the other one? Because look, the two 30 Newton forces are in which plane? Look, they are in plane
YZ.
Yes, they are in plane YZ. This means what? They will produce a moment about which axis?
Only X.
Exactly. They will produce moment about X. Now, who will tell me from the right-hand rule, it's a positive moment along X or negative one? Take your right hand, put your 4 fingers like this. So I should put my 4 fingers like this. Okay?
Negative.
Yes, negative. And the face of my hand is looking at the downward, at the force down. So my thumb will point like this. If you try to do it, my thumb will point in this direction, which is the negative X direction. Okay? So try to do it with your right hand. When you try to curl your hand from one force towards the other, your thumb will point in the negative X. So this will give me, the first couple is minus 30 times what? What is the distance between the two forces? I
500.
take yes, it is 450 millimeter. هلا, you can keep it in millimeter and then you will have a result in a Newton millimeter. Okay, or if you convert it to meter, you get your result in Newton meter. And it's along which axis? It's along I, so it's minus 30 times 450 along I. And the value is in Newton millimeter. So this is for the first force. Of course, here you can also use the vectorial method. Let us try it, and we will obtain same result. But it's easier here to do the right hand rule. If you want to do the vectorial method, what can you say? You can say I can take dc vectorial f. Okay, so this will be equal to dc vector vectorial f vector. Okay, what is vector dc? Vector dc is along y, positive y. Vector dc is plus 450 j vectorial vector force. What is my force vector? It's plus 30, it's minus 30 k, because as you can see, this, when I go from D to C, I take the minus 30 force. If I go from C to D, I take plus 30 k. Okay, so vectorial dc vectorial minus 30 k. Now j vectorial k, if I remember the circle, jk is turning jk I, it's positive, so plus I, and already I have a minus, so it's equal to minus 450 times 30 along I, so I got back to the same result. Okay, now for the second couple, you will see that for the second couple, it is easier to do the vectorial method. Why? Because as you can see, the second couple is not in a plane that is familiar. It's not in XY plane. It's not in a YZ plane. It's in an inclined plane. Why? Because look, if you join E to D, it is an inclined line. Okay? So here, in this case, this couple will have moments about different directions. And if you want to, first, the right-hand rule is complex here because the vector will be inclined. It will be a vector perpendicular to the plane of forces. So it will not be along x alone or y alone or z alone. In these cases, in general, I advise you to use the vectorial method. I will tell you how to use other methods, but the vectorial is the straightforward method. So if I want to use here the vectorial method, what can I do? I should take from, if I start from E towards D, if I go from E to D, I do ED vectorial, the 20 Newton in positive x. Or I can say it's DE vectorial minus 20I. So you have two possibilities and both will give you same result. So I can take ED.
Doctor,
Yes.
in the exam, you might ask us in an example like this to do both methods.
Look, in general, I give you the freedom, but it's good to know both methods because sometimes one is much easier than the other. So you will gain time. Okay? So be familiar with both methods.
Yes.
It's better.
Okay, thank you.
So if I want to use the vectorial method, I can do ED vectorial plus 20I. Okay? Now, concerning vector ED, for ED vector, I need to find just the coordinates of points. Okay? We have that, or you can see it easily here if you want. ED is 300 along K, because when I go from E to D, I go plus 300 along K, and I go down 225. Okay, along what? Along Y. So I can directly say that vector DE is plus 300K minus 225 J, or you can do the familiar method. You find the components of E, the components of D, and you subtract. But here it's easy to see in the figure directly the components of the vector. Vectorial 20i. Okay. هلا here for example to calculate this no need for a matrix لأنه you have little number of elements. So you start to say k vectorial I, ki is plus j, so it's plus 6000 j, and j vectorial I, ji is opposite to ij, so it's minus k. So, and you have minus, so minus minus plus, so plus 4500 along k. Okay, so this is the result of the vectorial method. Now, how can I verify this result by another method? Look, what you can do is you can say first, my two forces are parallel to x, so of course they will not produce a moment about x, and this is what I obtained. It's 0i. Now let us verify the moment about j. The moment about j represent what? Represent the moment about y-axis. Okay, it's the moment about y-axis. So now let us try to find together the resultant moment about y-axis. If I want to find the moment about y, I have two forces. I have this force and this one. Okay? If I start by this force, how you can calculate the moment of this force about y-axis? What should you do? You should multiply by the distance from the force to the axis. Okay? What is the distance of this force to axis y? It's 175. And if you do the right hand rule, if you curl your right hand, how your thumb will point up or down? Try to do it. So if you put your hand down, if you put your right hand like this, okay, your thumb will point downward. So it's a negative moment along y. So you can write along y axis, I have minus 20 times 175. This is the first force. Now for the second force plus 20, if you do the right hand rule now, how will your thumb point? It's opposite,
upward.
of course. It will point upward, and you should multiply by which distance to y? By this one, the whole one, which is 475. So it will be plus 20 times 475. Yes, 475. So you will get back the same result, which is, because if you do the addition, it will be equal to plus 20 times 300. Okay, so again, same result. And you can also see it in another way. The distance between the couple along z is 300. So the moment about y is the distance along this distance, which is 300, okay, times the force. While the other component along k, I will consider this distance because this distance will result in a moment about the axis. And if I do the right hand rule, if I curl my right hand, it will be clear that the moment will be in positive z, because I will turn like this. Like this, I will turn from this force to the downward one along z. If you curl your right hand, it will give you along plus z, and then you multiply by the perpendicular distance, which is 225. So again, you will get 4,500 along k. Okay, but of course now the vectorial is much easier, because if you do the vectorial method, no need to do right hand rule, no need to divide the components into y and z, and it will be more difficult to do the other method. While in the first example it was easier to do the right method. Okay, so along z you can directly say it's plus 225 times 20, and you get the same result. Okay guys, any question before we close? Okay, so hopefully on Friday, look, I will not give you all chapter 3 for the exam because it's a heavy chapter. So on Friday, we finish the part for the exam, and next week, we practice on moment and forces for the exam. Okay?
Doctor, for the
Yes.
exam, are the exercises enough to practice, or do we need to do extra exercises other
Yes,
than the
they
ones you
are
gave us?
enough. If you do all review problems, it's more than enough.
Can you please post previous also soon?
Yes, I will.
Okay, thank you, doctor. Have a nice day.
Okay. Bye.
Thank you, doctor.
Welcome.
Thank you,
Thank you,
doctor.
doctor.
Bye.